So welcome, Sumi, to our workshops. So I guess we know each other for almost what 5-6 years since we actually did the AA. Also, you did AA for about what 5 or 6 times in Shanghai already.
Yeah, forgot.
Yeah, it's been long. So Sumi has been teaching at AA and also teach at Bartlett some time, and then now she became the professor in SCI-Arc. This is the first year that you teaching.
Yeah.
You're teaching the bachelor degree and also master program, I assume. So she might be joining us in Shenzhen in September for the master program. We don't know yet, but hopefully she can join us. So as you know, she's actually one of the I would say her work I've kind of followed it a lot like lately. I mean, for the past couple of years. She has a very good aesthetics, maybe due to what she's been working with Saha for how many years? Like 8 years? 6 years. So she's been working in Saha office, in London office, actually. So she actually working with Saha actually for a long time. Did you ever work with Patrick?
Yeah, mainly. Yeah.
On which project?
Or more with Patrick.
Nanjing Tower?
Yeah.
Okay. But anyway, so she will be, I guess you will be teaching us some grasshopper technique, showing us some of the grasshopper technique, and also showing us some of her work. So anyway, so I'll leave it to you, and then so you can start. All right, thank you. Okay. You want to share the screen?
Yeah. Which screen can you see now?
Yep.
Which screen are you seeing? Can you tell me? Can you tell me which screen are you seeing? What can you see now?
Well, you can do full screen, no? Or
are you seeing a PowerPoint?
I see the PowerPoint, yes.
Okay, great. Okay, sorry. Yeah, so thank you, Stephen, for introducing. So today I was not going to introduce too much about myself. Sorry, Stephen, what are you saying?
It's a full screen, right? Or you actually minimize it? Yeah.
I minimize it before I start. I just want to say that if you are curious about myself more, I have more elaborate stuff here on my website, and you can just check out if you are curious. But today I'm not going to talk too much about myself. Instead, I will just talk about this workshop a little bit more. So why we are learning what we are learning today. So basically, let me see, this is not a good screen. Sorry. So I should share this screen. I should share this screen like this. Do you see a full screen now?
Yeah, it's a full screen. It's a full screen.
Okay, great. Okay, so okay, sorry. So nice to meet you, everybody. Sorry for the switching around. Okay, so today I'm going to just introduce a bit of my work and repeating a little bit of what in the introduction is. So I just joined SCI-Arc from this year, and you were taught by Casey the other workshop, and he's the coordinator of this program. And if you are more interested in learning with us, I think you can also have a look at this program in the future. Basically, my interest has been about the kind of abuse of computational power, computational coding, and try to utilize the generativeness and simulation kind of technique to generate interesting geometries and trying to understand those geometries architecturally, structurally, functionally, as well, so we can actually look at them in a fabricatable and executable geometries. So in general, if I summarize, that's kind of a work that can describe my work in general. So I work sometimes with 3D printing, robotically fabricatable geometries, machine fabricatable geometries, but also many of these geometries also should be considered in a larger spectrum, including the handmade crafting process as well. So that's why lately I was working with augmented reality a lot. So using augmented reality to assemble certain computer-generated geometries, but using human hand as crafting process. So here are some student projects, a combination of student project and practical projects that I have been involved, including in AA, Bartlett, and my practice called Suminham Design, with a team of, with a lot of collaboration and teaming up with a lot of different friends and students and professors in different fields. So lately, this one is the largest project that I have ever accomplished with under my name. Let's say my company name, together with Guili Jan, Cameron Newhan from Hologram, and Igor Pantix from Bartlett. So we collaborated this project as a augmented reality handcrafted timber boards, steam bent timber boards project, and connected with hand bent metal brackets, as you can see here. So this project involves a lot of hand labor, but the design is completely generated through algorithmic process, and that yeah, and that is actually celebrating a very short production chain between the raw material to the actual production, and that doesn't require a lot of preparation time, unlike any robotic processes, for example. So you don't need a high-level technician to build this. But of course, you can still say this is very contemporary building, and we won a few awards for this project. So I just want to kind of state that why this is relevant to do it today, even though it's probably not robotically made, or it's not involved any machine learning or drones or all these cool things. This geometry is made out of a lot of very simple parts. They are connected with 3-meter standardized timber boards that is coming out of the forest directly. And this has been connected in this manner and fabricated with human hand. This is a typical way of translating understanding a complex geometries in a generative manner, that rather than a parametric manner. So this is a diagram explaining how the parts are assembled to create complex geometries, and in this case using parts that are very precise, and all parts are different. And here you can see that the parts are related to each other very loosely, but the geometry itself is very simple and prefabricatable, for example. So the fundamental difference between, for example, a parametric pavilion or parametric structure, as you can see here by the very many, this is generated or fabricated by like a lot of different precisely fabricated laser cut parts. This requires a lot of machines and precision, and obviously the assembly labor and labeling of the parts. While these type of geometries, as I said before, this type of structure is fabricated through loose parts, self-similar parts, loose relationship to each other, with a lot of freedom to be able to connect to each other in a very free way. But being able to, the smartness in the assembly logic, so they can create still the complex geometries as a result. So I'm more interested in this, and this is actually enabled by the paradigm shift since around 20 years ago, when we can actually, as a designer, to code the basic underlying rules of the agencies of each agent. This is called object-oriented programming. This is fundamentally different from your modeling technique or modeling tool. Modeling is that you have a sketch, you want this geometry to look like that, and you model it. But in this way, is that you code the underlying behavior of these agents, and you cannot predict the overall geometry precisely, but you can actually control the overall kind of loosey relationship. So the control and generativeness is kind of happening together. So this is kind of a paradigm shift 20 years ago, let's say, and nowadays the computational paradigm is shifting again to use a data set to train a numerous neural net and generate geometries using a pre-experienced kind of design and geometries. That is a completely different thing, of course. But this is, I don't think that will replace this, because it's quite different. But anyways, I think it's that for that it's very important for us as designers to understand how this kind of structure is working, and it's not really a procedural modeling technique. So Grasshopper is, in general, very good in procedural modeling. It's not really good made for animating, like this kind of object-oriented programming, but actually using a few tricks nowadays you can do that, and today I'm going to show you how to do that. And by doing that, I will start from scratch. You will be able to learn these things step by step, and we are going to build a script called circle packing. So circle packing is, if you just Google or Wiki, you can see that it's really straightforward. It creates a packed geometries around these bubbles. Yeah, so they are all self-finding their own spaces. So just learning this simple rule set, so you'll be understand at least the structure of object-oriented coding, and that you can add more functions and behavior rules, and you can easily create the flocking behavior on top of that. And today, because of the timing, I think we are not going to code the entire flocking behavior, but I'm going to share with you a plugin that I have wrote, so you can actually run this behavior on your screen with this C# based plugin. So using this is an example using the similar logic to generate some kind of urban organization, for example. So this is a way of small, let's say, small example using this script. Another very simple example, I was using this to run a workshop with landscape design students, and we were planting a lot of different geometries with using this logic, and students were able to plant like really different geometries or their own plants or their installations in landscape. So this kind of things could have been done as well. In this workshop, we were able to we were also like trying to build this by hand. So students were using clay to build what they were designing and projecting the lights on top of their handcrafted model. So to be honest, actually, this workshop was really simple, but this was one-day workshop. If this were to be 3D printed, you could never really build this in one day, and in this size as well. So, so as a designers and architects, I think it's very important for us to understand what are the limitations and what are the freedoms that we have and how we can really use the technologies in a very creative ways instead of like stuck in a certain cool machineries that is available to us. Can you hear the sound? Maybe I didn't share the sound. Let me share this again. Sorry about that. Okay, so this one is a this one is with my students this year. We showcased it in spring show. So we were using the same exact logic that you are going to learn today to go through and go through this process with second year undergrad students, and we created a lot of like variations with students. They were able to create really interesting geometry, and we executed an app making exercise as well, so they could build it in AR. If you are interested in how to view your geometries in AR, I can also explain that to you. Okay, so last two slides, I want to just show how my undergrad students pushed this geometry design making into architecture proposal. And this year was about esports arena. So I showed this in the intro, I think. Maybe. Yeah, so this is a team of students developed this esports arena with this tool to generate geometries, and I think was quite successful is that second year students are kind of not very capable in the beginning to start to generate very complex 3D models, but by generating some kind of three-dimensional spaces and trying to understand and rationalize it into architecturally usable and functional spaces, I think then they were able to create some kind of quite intricate interior spaces instead of having a plan and extrude it, and the kind of process is kind of quite stuck in two-dimensional work. So okay, so this will be what we are going to learn today. So as a quick overview, you will be able to go through this today with me, and maybe hopefully at the end we will get a chunk of building and being able to produce a meaningful architectural space, and we can really also talk about that. And at the end, if we have more time, we can go to download this plugin, and we are going to run this, and you can also run a bit more complex flocking or complex system on your screen. Okay, so that's it for introduction. So do you have any question? Steven, you are mute. Steven, are you saying something? You are mute.
Yes. Can you hear?
Yes.
Well, first, congratulations on the Punk Pavilion. Is it the Punk Pavilion that you got the award?
Steampunk, yeah, steampunk.
That's very nice. So that was the award by the Digital Future.
Yeah.
I see. Well, that's how long does it take to build that entire pavilion?
We built it for 2 months,
2 months.
on site. Yeah.
So you basically fabricate some of the pieces off-site and then bring it over, and you
Yeah. So
fabricate the wood panel first and then bring it over to install, right? Or how did you prepare?
yeah. So we pre-bend them in indoor space,
Okay.
and once it's completely dry, we move it to the site and assemble it on site.
And when you prelam, I mean to make the curvature of the wood pieces, like how did you, what kind of technique that you use, or you use the VR, you know, the goggles to actually project it in the VR, like in the VR, or how did you do that?
Yeah.
I saw
So
you have a screen, I mean, that has all these sort of like variations, but then you're wearing a goggle. What is that for, actually?
Yeah, it's AR. And am I sharing my screen now or not?
Yeah, we can see.
I am. Okay. So yeah, if you are, I know you cannot use YouTube, right? But if you go to our YouTube channel, I uploaded our presentation from the Digital Futures.
Mm-hmm.
And this one, Project Over. And here we have a little bit more explanatory video here.
Wow, okay.
So what we did is we steamed the entire wood piece. And this,
Whoa, you steamed it.
yeah, it's a steam bending. Yeah, and we create this frame, and this is used AR.
So basically, you set up all the wood, I mean the location points, and then put the strip on top and steam it.
Yeah, so you'll see, yeah, this is how we steam it. So that green stripe is what Igor is seeing now. If you are wearing AR, you can see where this piece should be exactly.
It's very interesting how you using different media for design, like actually using the VR and then to help you to actually form the stripes, and you actually.
Yeah, so this is traditional steam bending process. So traditionally you need a mold.
Yes.
But
yes.
what we innovated is to go about this mold.
Mm-hmm.
So this was our early concept.
Mm.
So we are going to bend around the flexible mold, and then we developed this kind of mold system. So that's more fastly done with AR.
I see.
Yeah.
Is there any questions from the students? Maybe you guys can type in the Zoom chart. What's the plugin name? The image was blurry. Okay.
Which
one?
Oh, the plugin. So the plugin is, if you go to my website, I will go through this later, but if you go to link, there's Food for Rhino, and there is this plugin, or you can go to Food for Rhino Google SD platform, and you can download this too. This is really easy to download, so you can do it later as well.
Okay.
Oh.
Any other questions from the students? So what Sumi actually focus on, what I see from the past couple years is fusion between different media, you know, software plugins, and you know, like also combining with modeling technique. Everything is about, you know, the physical and the virtual reality. So everything is to be meant to be built. So a lot of the work that I see from Sumi is like at the end, it will have a physical, you know, actual model, or you know, actually build something. So that is very good for some of the students. They ask, you know, for some of the faculty where they always just in virtual reality or in digital, so never really produce anything that are, you know, physical. So I mean, it's great that to see Sumin is actually doing a lot of these physical work, and then just recently won the biggest, I mean, the award from Digital Future about the Punk Pavilion. That is amazing. So maybe we can learn more about what Sumi's you know, idea, and inspired by his approach of design. So let's start the workshop, and then maybe take a 5-minute break, and then answer some questions, and then we can start in like 5 to 10 minutes with the workshop. So could AR ensure the accuracy of the curvature? I guess the AR is more about, you know, looking it at, you know, as a reference, right?
Yeah, yeah.
So
yeah, we get this question a lot. Thank you, Guanxin, for the question. So it's not any handcrafting process is not accurate. It's naturally coming from your hand, isn't it? So like that doesn't do anything with AR or VR or whatever. But this kind of process is really good for something you have high tolerance in terms of making errors. That's why we kind of accidentally chose, because we like curvy geometry, that's why we chose curvy geometries, but actually it works much better for curvy and the double curved geometries and fuzzy geometries instead of very accurate like polished car or edged or like straight lines. So your design choice also should have tolerance for accumulating like or accepting like slight errors and differences.
And the advantage of using it is you can see it in life, and then you can see different angles, and it, you know, preview it right away, right? So it's not like, you know, rendering, you have to like, you know, render, you know, like some images and then look at it and build it, but you can actually,
it's real time.
See it. So that's the that's part of it.
Yeah, you can also change the digital model in real time. So
so what's the difficult part, like the most difficult part for building the pavilion?
Most difficult? Well, it is labor consuming and time consuming. Yeah, difficult. There were not much difficult if you compare to any other construction. It's similarly difficult and challenging, but I think it was relatively quite smooth. Also,
and what if I said if you want to reproduce this thing, like how much time and how much Like how much would it cost for making one in China, you think? Like including all the labors, design fee and everything, like what is the amount of, you know, sort of like a budget that you think you can reproduce one of this in different locations?
I'm really bad in math, but let's say you can put a month of time with maybe around 10 really good labor.
Mm-hmm.
Yeah, and you can calculate the labor in time and fee, and the board, the timber. Yeah. Yeah, it's compared to maybe robotics, it doesn't cost anything. Yeah.
What? How big is the pavilion? Like, I mean, it's 6 meters.
I'm going to publish this. No. This. Sorry.
Anyway, so did you produce the AR software in house, or are you using some other software?
So we were collaborating with Hologram. They developed this software. So it's connecting directly with Rhino to HoloLens. But you can actually do that with Unity and you build your own software. That's also possible. But we collaborated with them, and they are like genius designers as well. So you can just use that as well. Yeah.
I think for the future of Studio Alpha, maybe we can collaborating with them again, and then SCI-Arc initiative to have you to do a, you know, like a full 2 weeks to 10 days workshop in China, probably in, you know, the end of the year or beginning of next year. So when you have time, so so we'll look into that, and then maybe there's a lot more. Actually, I think there's a lot of students expressed they really want to have you as a workshop tutor. To do something.
Thank you.
So we
so
happy to organize.
today I really didn't thought I will lecture, so I didn't show too much of my work, but like all my work is on my website if it's working in China. And I'm going to also put some of my lectures on my YouTube channel, and I also noticed you are now using Bilibili a lot in China, so I will also upload it there as well. So students can see my full lecture. Yeah, if you're interested in.
All right, so let's take a 5-minute break, and then you can start the workshop, and Yu Liang is gonna help you with anything need to be assisted. Okay.
Yeah.
Okay.
Thank you, Stephen.
Thank you.
Thank you very much.